Hello everyone, hope you're doing incredible today. Today our focus is on vectors and scalar quantities. Hopefully we can learn what is the difference between them, the definitions. That's basically it because there's not much into it. You may think it's a very hard topic, but it's not. Let's jump right into it. So, let's start with scalars because they're the more simpler ones. The scalar quantity only has a magnitude, which is the same as size. And a vector quantity has that magnitude, that size, along with and a direction. And you may have heard the terms velocity and speed, and you may think what's the difference between them? Well, we'll learn about them right now. Imagine you have a ramp, like a right angle triangle. That is a very bad ramp. Better. Okay. And you have, well, as this ball is rolling down, it is covering a distance, for instance, 10 meters. And it has a speed. And listen to the term speed here, because it is technically correct if you use it in a specific way. For instance, say it covers that 10 meters in 2 seconds. Okay, 2 seconds. So if we use the speed equals distance over time formula, we'll get this, that the speed is equal to 10 over 2, which is equals to 5 meter per second. This is just a different notation with the power of -1. So what this means, this isn't a vector. Like, listen to the definitions. A scalar quantity has to only have a magnitude or a size. But as a vector, it needs to have a direction. Did we specify the direction? Did we specify that it is going southeast, for instance? We didn't. So 5 meters per second is just a scalar quantity because it only has a size of 5 and has a unit, but the unit is not the actual quantity. Now, if we specify that it is going, for instance, now if we say that it is going 5 meters per second in the direction of southeast, now this would be a vector quantity because we're specifying the direction that it is going. We're not just saying the size of it, the quantity of it, that it has a speed of 5 meters per second. We're also saying that it is going in a specific direction. We're giving more information about it, and that's what vectors are about. They have a direction and they give you extra information about what is actually happening in a problem, and that leads to the different quantities that we have. So let's practice something right now. I'll give you one quantity and you can guess which one it is for. Displacement, which I like to define it as the shortest length between 2 points, the fastest length. Like, not the actual path that the object has taken, that will be distance, but displacement is the shortest path 2 points can have from each other. For instance, imagine you have these 2 points. This could be your distance. This is how much you've covered, that an object has covered. However, this would be your displacement, the shortest path possible. And a displacement is a vector. You always use displacement as a way to also give the direction. So when you're talking about displacement, you will say 2 meters to the right, 2 meters to the left, north, south, whatever. And that's what makes velocity different from speed. Velocity is displacement over time, which you write as s over t. This s is not to be confused by speed. This is for displacement. Surat equations, basically. But a speed is going to be distance over time. So this is scalar, and this is a vector. Speed has a distance which has no direction, just a magnitude, 5 meters per second, as we saw earlier. And velocity has displacement instead of distance, which means that it gives you direction. So you have to use which direction it's actually going when you're defining the displacement or velocity of an object. And that's basically it. There's a difference between velocity, speed, displacement, distance, what scalar quantities are, what vectors are. Hope you learned something. If you had any other questions, let us know in the in the comment section, and we will come back to you. Hope you enjoyed it. Give us any feedback you have. See you next time.